Welcome to a new lesson. But what is today's lesson? Let's see. Elements that belong to column 16 in the periodic table are oxygen, sulfur, selenium, tellurium, polonium, and livermorium. And elements that belong to column 17 in the periodic table are fluorine, chlorine, bromine, iodine, astatine, and tennessine. We know that elements of any specific column are almost similar in properties. Based on this point, today's lesson I am going to write. That is, here sulfur with fluorine can form sulfur difluoride, sulfur tetrafluoride, and sulfur hexafluoride. Here oxygen belongs to the same column of sulfur. So oxygen and sulfur should be similar in properties. But oxygen with fluorine can form only oxygen difluoride, but oxygen tetrafluoride and oxygen hexafluoride cannot be formed. So oxygen and sulfur belong to the same column, but sulfur with fluorine can form sulfur difluoride, sulfur tetrafluoride, and sulfur hexafluoride. But oxygen with fluorine can form only oxygen difluoride. But oxygen tetrafluoride and oxygen hexafluoride cannot be formed. But why? This is today's lesson. Let's go to the detail. First of all, let's see electronic configuration of fluorine. Because in these compounds, fluorine is sp3 hybridized. Let's see hybridization state of fluorine in these compounds. Fluorine, atomic number is 9. Electronic configuration is 1s2, 2s2, and 2p5. When electronic configuration of fluorine is drawn in box method, then we can write this one: 1, 2, and 3. This is 2s, 2ph, 2py, and this is 2pz. Outermost orbitals. Here 2s orbital contains 2 electrons and 2p orbitals contain total 5 electrons. 5 electrons will enter these orbitals according to Hund's rule, one by one. 1, here 1. 3 electrons are distributed. 4 and another one, that is total 5 electrons. In these compounds, fluorine undergoes sp3 hybridization in the outermost shell. That is sp3 hybridization. The orbital structure of fluorine in this compound is fluorine. 4 orbitals take part in hybridization. So 4 new orbitals are formed. Hybrid orbitals. This is one sp3 hybrid orbital. Another one, another one, another one. 3 orbitals contain 1 electron pair each, and 1 hybrid orbital contain unpaired electron. This is the orbital structure of fluorine. That is, fluorine contains 3 lone pair of electrons and 1 unpaired electron. These 3 lone pairs of electrons remain freed, but this unpaired electron takes part in bond formation. Now let's see electronic configuration of sulfur. Sulfur 16, 1s2, 2s2, 2p6, 3s2, 3p4. Sulfur is of third period element, so it has 3d sublevel, but up to 3p 16 electrons have been arranged, so 3d orbital remains vacant. Now let's write electronic configuration of sulfur in box method. Sulfur outermost orbitals are 3s, 3p and 3d. 1, 2, 3, 4, 5. In the d sublevel there are 5 orbitals. These are 3d xy, 3d yz, 3d zx, 3d x square y square, and last one is 3d z square. And 3p orbitals are 3px, 3py, 3pz, and this one is 3s orbital. 3s orbital contains 2 electrons. Electrons will enter first lower energy orbitals according to Aufbau principle. Then 3p orbitals contain 4 electrons, 1, 2, 3 and 4. But 3d orbitals remain vacant. Now let's see formation of sulfur difluoride. Sulfur difluoride. In sulfur difluoride, sulfur is sp3 hybridized, that is s and these 3p orbitals. Sulfur sp3 hybridized. Orbital structure is sulfur 4 orbitals, 1, 2, 3 and 4. Out of these 4 orbitals, 2 orbitals contain 1 pair of electrons each, and another 2 orbitals contain unpaired electrons each. With this orbital containing unpaired electron, fluorine forms bond with its hybrid orbital. Here fluorine, and fluorine contains 3 pairs of electrons. So this is the compound sulfur difluoride, which is V-shaped because here sulfur contains 2 lone pairs of electrons. Here lone pair bond pair repulsion occurs. That is why this molecule gets bent shape. Now let's see formation of sulfur tetrafluoride. Sulfur tetrafluoride. In this molecule, sulfur is sp3 dehybridized. That is, here sp3 dehybridization occurs in this way. When sulfur gets excited, then 1 electron of 3px orbital shifts to the vacant 3dxy orbital. Now we get this structure: 3s, 3p and 3 d orbitals, 1 2 3 4 5. S orbital contains 2 electrons. The 3px orbital now contains 1 electron and 1 electron shifted to d orbital. Here 2 electrons. Now sulfur experiences sp3 and d, that is sulfur sp3 d hybridization occurs here, and the shape of these orbitals is like this: one sp3d orbital, another sp3d orbital, another sp3d orbital, another one, and last sp3d orbital, which contains one pair of electrons, this electron pair, and another 4 orbitals contain 1 electron each. With these 4 orbitals, 4 fluorine atoms form sigma bond with its sp3 orbital. Fluorine, here fluorine. So this is the molecule of sulfur tetrafluoride. Here this is trigonal bipyramidal shape. Simply we can write sulfur, fluorine, here fluorine, fluorine, this is fluorine, and sulfur contains 1 pair of electrons. Here the bond angle is 187 degree instead of 180 degree, because here lone pair bond pair repulsion occurs. That is why this bond angle is expanded to 187 degree instead of 180 degree. That is, here sulfur tetrafluoride is formed because of the presence of d orbital, vacant d orbital. So here d orbital is responsible to form sulfur tetrafluoride, and its shape is trigonal bipyramidal. Now let's see formation of sulfur hexafluoride. Sulfur hexafluoride. In sulfur hexafluoride, sulfur is sp3d2 hybridized. sp3d2 hybridization occurs in this way: when sulfur gets excited state to the second step, then 1 electron of 3s orbital shifts to the vacant d orbital. Now we get this configuration: 1s, this is 3s, this is 3p, and 3d, 1 2 3 4 5 orbitals. Now 3s orbital contains 1 electron because 1 electron shifted to the vacant d orbital. Here 1 electron, and d orbitals, here 1 electron, and this electron shifted here. So now in the valence shell of sulfur there are 5 unpaired electrons. Those are in 3s, 3p, and 3d orbitals. So here sp3 and d2 hybridization occurs. So sulfur faces sp3 d2 hybridization, and orbital structure is like this: sp3d2, sp3d2, sp3, this one and another one. Total 6 orbitals, 1 2 3 4 5 6, because 6 orbitals take part in hybridization, and after hybridization 6 orbitals are formed. Those are similar in structure and similar in energy. This is hybridization, and with these 6 hybrid orbitals, 6 fluorine atoms form bond with its hybrid orbital, that is sp3 hybrid orbital of fluorine. Here fluorine, 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 here fluorine as well. So this is the way sulfur hexafluoride is formed. The simply shape is like this: fluorine, here fluorine, this dotted line means inwards from the surface of the board, and solid line means outward from the surface of the board, and these lines mean on the surface of the board. So its shape is octahedron. Now we see that sulfur difluoride, which is bend shaped, then sulfur tetrafluoride, which is trigonal bipyramidal shaped, and sulfur hexafluoride, which is octahedron in shape, and sulfur tetrafluoride and sulfur hexafluoride are formed due to the presence of vacant d orbitals. Vacant d orbitals are responsible for making increased number of unpaired electrons. These d orbitals help to make increased number of unpaired electrons. So sulfur tetrafluoride and sulfur hexafluoride are formed for the presence of vacant d orbitals. Now let's see formation of oxygen fluorides. Oxygen 8. Electronic configuration is 1s2, 2s2, 2p4. Total 8 electrons. Let's write electronic configuration of oxygen in box method in the outermost shell. 2s and 2p. 2s orbital contains 2 electrons and 2p orbitals contain 4 electrons, 1, 1, 1 and another 1 according to Hund's rule. Now let's see oxygen difluoride. Here oxygen undergoes sp3 hybridization. Oxygen sp3 hybridization, and shape is like this. Total 4 orbitals. Here 4 orbitals, 1s and 3p orbitals. 2 orbitals contain 1 pair of electrons each. This is 1 pair of electrons, 1 pair of electrons, and 2 orbitals contain unpaired electron. This unpaired electron makes bond with a fluorine in this way. So this is the way fluorine difluoride is formed. Oxygen contains 2 lone pair of electrons. Because of this lone pair of electrons, this molecule gets bent shaped or V-shaped. But here, to form oxygen tetrafluoride and oxygen hexafluoride, here formation of unpaired electrons should be formed. But as oxygen is the element of second period, it has no d orbital or d sublevel. As it has no d sublevel, so oxygen has no d orbitals, and for this there is no scope to increase number of unpaired electrons, because here these electron pair cannot break, because in this case there is no vacant d orbitals like sulfur. So as oxygen has no vacant d orbitals, only oxygen difluoride is formed. But oxygen tetrafluoride and oxygen hexafluoride cannot be formed because of the absence of d orbitals. This is all about molecule formation of sulfur difluoride, sulfur tetrafluoride and sulfur hexafluoride. Oxygen difluoride is formed, but oxygen tetrafluoride and oxygen hexafluoride are not formed. Now today, thank you very much.